Welcome to Accelerate Science Now, where we sit down with innovators shaping policy, research, and industry to ask one big question. How do we make science move faster and work better for everyone? Today, I'm joined by Vasileios Maroulas, professor of mathematics at the University of Tennessee, Knoxville, and director of the AI Tennessee Initiative, a statewide effort to position Tennessee as a leader in the global data economy. We talk about how his work using topology and geometry helps detect hidden patterns in scientific data, what it takes to build a statewide AI ecosystem that connects universities, industry, and national labs like Oak Ridge, and why the next generation of scientists should think of AI as infrastructure rather than just a tool. Enjoy the show. Today, our guest is Vasileios Maroulas. He's a professor of mathematics at the University of Tennessee, Knoxville, where he also serves as associate vice chancellor and director of the AI Tennessee Initiative. His research applies AI and data science to complex scientific problems across fields, including biology, medicine, material science, and national defense, with a wide range of support from the Department of Energy, Department of Defense, the National Science Foundation, and Oak Ridge National Laboratory. In his current role, Vasileios is working to build UT into a national hub for AI research, education, and workforce development. So, Vasileios, thank you so much for joining us today.
Thank you very much, Adeline, for the opportunity.
Yeah, great. Well, we always like to start out asking a question. If there was something early on in maybe school, just in life generally, that made you know for sure you wanted to pursue a career in science and technology.
Sure. So first of all, let me say that indeed, as a young person back in Athens, Greece, where I grew up, born and raised, I wanted to follow something related to science, technology, mathematics. I found mathematics extremely interesting as the language of the universe, the language that, in some sense, explains a lot of physical phenomena. Yeah. Always, my mathematics to have an impact in science, but also in society. And therefore, I focused on applied mathematics. And as soon as I finished my bachelor's degree at the University of Athens, then I moved to the United States to pursue a PhD in statistics. So data has always been extremely important to me. And of course, the data conversation is so much critical into the AI domain that I will speak right now. So, yes, so the answer is indeed. I was very much interested from early on, and I kind of followed that trajectory where I am.
Great. Yeah. Well, it's always really nice to hear that it always came from a bigger place of wanting to make an impact on society. And so, really great to see that you followed that all the way through. So, was there something in particular that drew you to statistics specifically as the foundation of your work earlier in your career?
Yeah, of course. Again, statistics, like at the heart of statistics is data.
Mhm.
And these data are just numbers that they represent a phenomenon, numbers that they represent something that we really care about. It is like a collection of numbers organized in a certain way that explains the underlying pattern. And statistics does that. So it gives you a model that would explain these random numbers, or at least they appear to be random, to be organized in a certain fashion. So that's kind of what drew me into statistics. And of course, the data itself is like, if you want to view it from a social impact point of view,
Mhm.
data itself perhaps represents opinions of perhaps represents social sort of phenomenon, and therefore it kind of this organizing pattern that statistics is trying to detect, then it will give you an answer to it. By the same token, in science, the same. You try to detect a needle in a haystack, let's say a rare event, then statistical modeling will quantify, some of these uncertainties. It will quantify, it will give you again a pattern, a distributional pattern of the data itself. So
Yeah, really fascinating. Definitely a mathematical way to view the world and identifying those patterns. So yeah, that makes a lot of sense why it's something
absolutely,
you're
sometimes I'm dreaming of numbers.
I can't say the same, but that's really fascinating. So after your PhD, I know you went to be a Lockheed Martin fellow. That's a very interesting combination, mathematics institute funded by a defense contractor. What did that experience teach you about the relationship between fundamental research and real world application?
Yeah. Um, as I mentioned to you, I always wanted to, my mathematics, my statistical modeling to kind of answer a bigger question, a question that is very concrete. It is quite challenging. At the same time, is to arrive to a solution is extremely messy. So you need to kind of like view it in multiple different ways. Collaborating with industry, kind of like, a bigger problem, a bigger umbrella problem was given to me. And then I had this unique opportunity to deploy my mathematical sort of a statistical background to provide to provide a solution. The solution by
Hmm.
means is the panacea. It's just a solution that pushes a little bit the boundaries of the unknown a little bit more, a little bit further, but by no means is the absolute, the master solution that is going to, you know, it's going to be a unique sort of approach to that challenge. So that exactly this collaboration taught me that sometimes a bigger question is given to you, and then if you parse it in a certain way, you could contribute something to it, but that something fits in a bigger picture that sort of uh, will provide the framework and will push the boundaries of the unknown a little bit more. But it's not the end of the story. There is way more work to be done.
Hmm.
Your collaborators, where perhaps collaborators speak a different language than you, language in a sense of what their scientific or engineering background is coming from. So that is another challenging aspect. How we can start communicating in a way that we understand each other and we are after the same goal, or perhaps parallel goals that they will dissolve in that bigger problem.
Yeah, that's really beautiful, and I think speaks a lot to something I want to get to in a bit, which is the AI Tennessee initiative and like working with very different collaborators that are, yeah, speaking very different languages but have a similar goal. Maybe first, before we get to that, you've been at UT Knoxville for I think over 15 years now.
That's right.
What has made you want to stay and build your career there? What's so special about UT Knoxville?
Yeah, so a lot of things are very special about UT Knoxville. So I came here in 2010, and almost 16 years later, I'm still here. Just to draw a parallel, as I mentioned, I was born and raised in Athens, Greece, and now I've been living the last 16 years from a European state, from a European country in Greece, all the way to a state in the United States, whose capital is the Athens of the South. And we have the Parthenon. So um, that sort of historical framework reminds me of back home. And I'm really appreciative of that. But Knoxville itself and the university is a very dynamic campus, is a university that strives for innovation, is a university um, whose research keeps increasing, and we certainly we want to be well known for several things, and several research topics. But at the same time, as the land grant university, we want our impact to have, we want our research to have an impact in for all Tennesseans, and we would
Hmm.
like to, to help our fellow citizens to sort of have an impact across the entire state of Tennessee and make life and lives in Tennessee better.
Yeah. And so I think it would be great to hear maybe first what the mission statement of the UT, or sorry, yeah, the AI Tennessee initiative. And then I'd love to hear like how it got started, when that was, whose idea, what made you realize this was something that needed to be done.
Yeah, so AI Tennessee is a statewide initiative led by the University of Tennessee in Knoxville, with a very simple but yet very bold goal to position the state of Tennessee a leader in the global data economy. So the initiative started approximately 4 years ago, and the leader back then was Dr. Lynn Parker, who was she was an associate vice chancellor here. She was also a faculty at the University of Tennessee, Knoxville for a really long time, and born and raised in Tennessee as well, not very far from the UT campus. But above all, she has served the entire nation as at the White House as the deputy at the Office of Science and Technology Policy. Um, so the way we organized the AI Tennessee is supported by 5 pillars:
Hmm.
research, um, education, infrastructure, partnerships, and outreach to communities. So these are the 5 pillars that they support the initiative. So I worked as a deputy, and then as soon as when she retired, and actually officially she went back to the White House for some period of time, I stepped up to this role. Um, and I am in this position the last 2 years or so.
Great. I'd love to hear, maybe some concrete examples of the really exciting work that AI Tennessee has been able to do within the state. Are there any like, cool partnerships or specific outcomes that you guys have seen from your work?
Yeah, absolutely. So first of all, let me start by saying that AI Tennessee is an effort that is impacting the entire state and is embodies 300 plus or so members across the entire state. Um, so one may view AI Tennessee as the convener and a coordination group that brings leaders from the state government, industry, and universities all together on what I call the Arthurian roundtable of collaboration around artificial intelligence. This past March 25 and 26, for example, we brought together 500 people that they wanted to they are contributing to the artificial intelligence here in the state of Tennessee. That was the AI Tennessee Summit. We had great representation from the state government, also the White House, Dr. Klein, the CTO of the White House. We're honored to have him. Um, industry leaders, industry leaders that not only use artificial intelligence, but also export, if you allow me to say, artificial intelligence. So, for example, we have folks from XAI, We had folks from NVIDIA,
Mm.
and the AMD, and some companies as well that use artificial intelligence to benefit for benefiting their product.
And 300 members, I would imagine there's a huge range of who's in that. What are some of like the, maybe smaller companies or maybe
Yes,
more unexpected members that are part of the coalition?
yes. So we have a really large number of smaller companies. So for that particular reason, we launched back in March 2025 an industry consortium. We call it AI TechX. And the idea of AI TechX is industry brings a data challenge, and then an AI Tennessee researcher provides an AI solution to that specific challenge. So we try to establish a two-way, a bidirectional conversation uh, where industry impacts our research directly, but also researchers at the universities collaborate directly with industry partners. Now, in this conversation, we are intentional and we bring startups as well for various reasons. One is to have these folks together with Fortune 500 companies. They get mentored.
Mhm.
They progress in their business journey, and potentially they might be, acquired some of these Fortune 500. So we generate IP together
Wow.
with smaller startups and researchers at the universities. And the goal is to develop a framework um, for innovators to innovate in Tennessee and create these opportunities that there's going to be an economic prosperity to the state. And we start early on from that, not just like the faculty, but also postdocs or graduate students or even undergraduate students. They're like born and educated in Tennessee, and then they
Mhm.
find the right opportunities for remain in Tennessee, kind of contributing to the brain gain of the state, so to speak.
Yeah. Wow. What a fantastic program and such a great way for students. Yeah. Not only to find those opportunities, but to get like the hands on experience and learning while they're still in the classroom. That's really exciting.
Absolutely.
Yeah. Well, I'd love to pivot a little bit and talk about some of, your research, which you're doing on top of being director of AI Tennessee. I know that, as we mentioned, your research uses AI and data science to find those complex patterns within data. I know you're working in many different fields: biology, medicine, national defense. How do you explain to somebody outside your field, like what it is that you're doing in your research? What is like your elevator pitch of all those broad areas?
Yeah. So if I want to summarize it with one line, I call it um, data has shape and shape matters. So this is exactly how I develop algorithms. And in order to detect the shape patterns that they are in the underlying data. So it's either material science or biological or medical images. Then this approach of shape detection is sort of my scientific hammer. And the way to do that is with a method that I have developed that engages, um, you know, topology and geometry combined with statistics, something that I call TAI, topological artificial intelligence.
Hmm. Great. Yeah. Well, I love that. Data has shape and shape matters. That's a very good, very good tagline. I know your lab has received funding from a pretty wide range of sources, Foundation Oak Ridge, private foundations. How much does it matter where your funding comes from, and how does it shape the research questions that you're pursuing?
Right. So, first of all, working with the federal government, you have a unique opportunity for your research, someone's research, to plug into the national mission. Okay. So, as you can imagine, between Department of Energy or Department of Defense or Department of USDA and so on and so forth, the mission, the critical mission is shifting depending on what kind of solicitation you're trying to respond to. Now, the beauty with statistics or mathematical sciences in general is, as I mentioned to you, is sitting at the cross-cutting of a lot of science and engineering. So the beauty with that is it is very agile and very flexible to sort of take your approach and plug it in various other domains and of science and engineering, therefore responding to various other solicitations coming from different departments. Of course, within every single sort of application, a lot of different things are changing. I'm not saying that you can just use as a black box your approach to every single, uh, scientific question. But as I mentioned to you earlier, the topological artificial intelligence and detecting shapes of data is my hammer. So I deploy such techniques where I'm able to see patterns, shape patterns in data coming from the energy domain or coming from, the defense domain. Now, working with data is a little bit different because the industrial challenge not only requires a solution, but requires that solution to be computed very, very fast sometimes. And you need to scale it up in a ways that, some of the very expensive, quote, quote, mathematics and the hardcore, maths that they go in these algorithmic developments. Yes, they are very rigorous. Yes, they are very robust. But if you try to compute them on the fly, let's say if you are monitoring, an adversary, and speed is very critical, then some of these approaches might not cut it. So the industrial challenges is kind of like a game between speed and accuracy, and sometimes those two can be very orthogonal.
That makes sense. And on that note, I mean, AI is moving so fast. I mean, I was thinking when you're saying that the AI Tennessee initiative started five some years ago, that so much has changed since it started. It's crazy. But on the speed and accuracy note, I know that there's real concern about, whether the tools are outpacing scientists' ability to verify, interpret, and trust the results. How do you think about that relationship between speed and rigor, and how do you use it in your work?
Yeah. So first of all, I'm going to give you a little bit of a different answer. If you look at AI just as a tool, certainly constant updates of these tools will be coming your way, and then you can look at the tree while you're losing the forest, so to speak.
Mhm.
And why I'm saying that is, I believe we should be looking artificial intelligence as an infrastructure, as something, as a system that holds this unique opportunity to push the scientific boundaries of the unknown a little bit further, maybe a lot further in certain aspects. And if we have the right, the compute, the models, the data, then we don't necessarily have to this question, and we don't necessarily have to choose between rigor and speed, because speed, maybe rigor comes at a fast pace. Okay, so again, there is a lot more going into the AI than just like, the latest and brightest. And viewing it as an infrastructure is the right base for moving forward when it comes to AI.
A really helpful way to think about it. So you're based at a university that sits right next to Oak Ridge National Laboratory, which is, one of the most significant scientific research institutions in the U.S. How does that proximity shape what you and your students are able to work on?
Yes. So yes, that is correct. But it's not really the geographic proximity that plays that plays a role. First of all, UT and Oak Ridge National Lab, they kind of have worked together post Second World War when it comes down to innovation.
Mhm.
There is an excellent book which discusses the history of the developments at the Oak Ridge National Lab, and in parallel and in tandem with the University of Tennessee, Knoxville, by my colleague Lee Riediger. So
Ah,
someone might be interested in that.
we'll have to
It's
plug
an
that
excellent
after.
book.
Yeah, that's
Yeah,
great.
absolutely. Um, so, but three things are kind of good drivers for and kind of gives you this unique relationship that we have on the Oak Ridge National Lab. First of all, access to real scientific missions. Okay, so our students and researchers engage with an environment which is not a suit of toy or instructional problems, but actually engage with problems that matter at the national level. Okay,
Hmm.
so I spoke before about plugging into the national mission. Um, Second, there is an exposure to infrastructure that universities typically don't have. So HPC in later this year or next year, I can't recall, we're going to have an AI supercomputer. And then in 2 years, there's going to be, yeah, I think it's this year, this summer, and then quantum enabled on top of that. And then in 2 years from now, the Oak Ridge National Lab is going to have a second one, the Lux and Discovery. These are their names. Also, advanced experimental facilities, right? So having access to that, the question now shifts, um, not kind of what model to train, but what system can I deploy, can I build at scale? And last but not least, we have the so-called UT Oak Ridge Institute of Innovation, which blurs the line between university research and national lab capabilities.
Wow.
So faculty at UT and lab scientists are working together, and they educate the future generation of scientists and engineers there, who, and basically they develop the workforce that they understand or they have seen what it means to work in a problem of national mission. So, for example, we have 3 PhD programs that they are within UTORI. That's the acronym for that, the
Mhm.
UT Oak Ridge Innovation Institute of Innovation. Is the PhD in data science and engineering, which was one of the very first PhD programs in the nation, in the United States. The other two is energy science and engineering and genome science and technology.
Wow. Well, this one of the questions I wanted to make sure that we got to was, about developing the scientific workforce and how universities do that. And I feel like you've been answering that question. I think with almost every answer you're doing, UT Knoxville is clearly doing so much exciting work to bring these opportunities and develop that scientific workforce. So I guess to reframe the question, what would your advice be to universities that, don't have this pre-existing relationship with state-of-the-art research facility like Oak Ridge? What would your advice be to make sure that we are developing that scientific workforce that is needed to keep the United States competitive in AI?
Yeah. So first of all, let me say that universities still do a very good job at fundamentals. Okay, with its mathematics, statistics, machine learning, domain science, and engineering. So perhaps where we fall short sometimes is not exactly what we teach, but how these pieces come together in practice. In my opinion, students and researchers truly need three things. Okay. So first of all, I mentioned one already. AI, see AI as infrastructure, not just as a tool. Okay. So AI, for example, is becoming part of any underlying structure of an organization. So data pipelines, compute, deployment, integration into workflows. So we need to kind of start thinking along this way and find a new way to educate, to do education along these lines. Okay. So second is the ability to operate across boundaries. So the applications of AI, health, manufacturing, supply chain, so to speak, so to say, so needs viewpoints and brain power, if you like, across different silos. But yet we educate our students in very departmental boundaries. Here is where you do your math. This is where you do your statistics. This is where you learn about manufacturing materials. We kind of need to stop thinking that way because AI permeates so many different disciplines, and that's actually the opportunity. I don't know, maybe to go and become Renaissance scientists, where we speak multiple languages. Yes, we have our accent, okay? As for example, we speak in English and I have an accent. But if mathematics is your background, certainly you're going to have an accent, a mathematical accent. But you will be solving and you would be working with someone who is a material scientist and understands the chemistry and some of the mathematics. So that kind of thing. And of course the third thing. So AI is infrastructure one. Your ability to operate across boundaries, and the third thing is work with real constraints. A lot of time when I am with my colleagues from Oak Ridge or other industries, when we try to showcase our model, uh, and we test it on data. This data is very clean, very staged. The way we would like them to behave the way they behave. However, in practice, it's not like that. We don't have an abundance of data. We have very limited data. And the data might come in very strange forms and shapes that these beautiful models that we are solving, we are using on the state's data, everything is out of the way. So you need to start thinking totally different. So students need to get exposure early on these sort of peculiarities, these difficulties um, that you know real problems, industrial or coming from a national lab, because they plug into some sort of national mission, then it's not going to be a perfect war.
Great. And that I think bleeds really well into my final question as we wrap up here. Kind of flipping the narrative on, you've been working with students and postdocs and undergraduates, for a long time now. With your students today, what do you tell them? Like, what do you want them to know most about the opportunity in front of them right now and how to make the most of it?
I mean, the opportunity is doesn't have any sky is not the limit anymore in this opportunity, right? Um, which means plug into your creativity and use artificial intelligence as your collaborator to whatever you're trying to accomplish. Um, I'm not gonna, of course, there are issues with the technology itself. And I don't mean to be repetitive with the hallucinations and the biases and all that. That is for sure. But if I had this tool when I was a graduate student, which I mean, I recall many times when I was trying to look into something more concrete, something you know, very it was a very direct question that I had back in the days when I was doing my PhD, but I had to learn. I had to read, I don't know how many pages and how many books
Yeah.
to get to the point. So now the opportunity here is artificial intelligence brings in front of me very quickly, so I can scale up my research. At a pace that I couldn't even imagine before. And certainly I see this, I see the technology as from an optical standpoint, from being optimal and because that's what I am by nature, uh, um, so so to summarize, use your creativity, use your imagination, and deploy artificial intelligence in the ways that they could help you out.
Great. Well, Vasileios, thank you so much for both joining us today, taking the time, and also the really exciting work you're doing at UT. It's so appreciated.
Thank you very much, Adeline. I appreciate the opportunity.
You've been listening to Accelerate Science Now. I'm your host, Adeline DeYoung. This show is produced by Kindred Subjects, Accelerate Science Now, and Seed AI. Our executive producers are Josh New and Austin Carson. Special thanks to Kevin King for editing and production. Thanks for joining us, and we'll see you next time.